Hello friends, in this video we will see how we can relate potential energy to the force. So this problem says, in a force field, the potential energy of a particle is given as U is equals to A by R square minus B by R, where A and B are positive constants and R is the distance from center of the field. We have to find the distance of equilibrium position from the field center, and we also have to find if it is a stable equilibrium or unstable equilibrium. So how will you do this problem? If you remember, the force in the radial direction is related to minus du by dr. Basically, this is a vectorized formula, so we can also write vector Fr is equals to minus du by dr Er, and in that case we can take magnitude of this, that is du by dr. So I can write du by dr, magnitude of this times Er with a negative sign. So this is a unit vector. So this is a basically unit vector. So now, if you want to analyze magnitude of forces, in that case you have to see only this term. This term comes for direction. So this is very important. So this term is responsible for direction and this term is responsible for magnitude. So if you want to maximize, minimize, want to see zero position of magnitude, then you have to only consider this portion. You don't have to consider minus unit vector direction, because that is a simple direction. So let us say now we can find, so U is given A by R square minus B by R. So we can find du by dr. Basically in this case U is only a function of R. So if you differentiate this, you will have this becomes minus 2a by r q, and this will be plus b by r square. Now this is basically force in the radial direction. So we have to find position of equilibrium. So the distance for which equilibrium position exists. So this means we have to find r. So at equilibrium we know that forces is equals to 0. So from here we can say 2a by rq is equals to b by r square. This means from here we can further say r is equals to 2a by b. So at position r is equals to 2a by b, we will have equilibrium. Forces are 0 and this r is measured from center of the field. We have to also find whether this is a stable equilibrium or unstable equilibrium. In other words, we have to find whether that is d2u by dr square. So mathematically we have to find whether this function is greater than 0, less than 0 or equal to 0. Dependingly we can have a stable, unstable or a neutral equilibrium. So let us find this differentiation. So what we will have, so this term is there, and if you differentiate this term, so you will have 6a and this divided by r4 minus 2b by rq. So this term, now let us plug the value r is equals to 2a by b and let us find what is the value of this term. So r is equals to, so we have to find this expression for r is equals to 2a by b. So we have to plug r is equals to 2a by b. So if you plug this, you will have 6a divided by 2a by b raised to the power 4 minus 2b divided by 2a by b raised to the power 3. So if you calculate this, this will be simply 6a divided by, so this will become 16 a4 by b4. So let us take b4 on the top and minus this will be 2b divided by 8aq and this pq on the top. So what we will have? So if you calculate this, this will become 3 by 8 and this is B4 divided by AQ minus 1 by 4 B4 divided by AQ. So this term will be, so if you take 8AQ in the denominator, you will have 3B4 minus 2B4. This will be B4 divided by 8AQ. And now B and A are positive constants. So this means this term is greater than 0. So if this is greater than 0, this means there is a minimum exists. So this corresponds to minimum. So minimum potential energy. So this corresponds to minimum potential energy. This means what kind of equilibrium we have? We have a stable equilibrium. So this is a case of a stable equilibrium. Basically, you can plot this potential energy diagram also. So let us say you have something like this. Now, I am not exactly plotting, but you have somewhere something like this. Then what will happen? This is your position of equilibrium. So this distance from r equals to 0, this distance is 2. What was this? So this is 2a by b. So this distance is 2a by b. And there is a minimum. This means if you move this side, this block will come again here. So if you put a ball here, just try to understand analogy. Then if you move this side, this will come again here. If you move this side, this will come again here. So this means this is a equilibrium of a stable in nature. So this is a stable equilibrium. So this is a stable equilibrium. So this concludes this video. Now question for you. So you see, we calculated what will be the force at this position. Basically, if you move this, if you go a little bit this side, force will have a tendency to come back again in the mean position. If you go this side, force will have a tendency to come in this side. So this means this potential field basically corresponds to a simple harmonic motion. So you can equate the forces by displacing by a small amount of r, and then you can find time period. So let us find time period for this potential field and discuss in the comment box. Another question in this case is, we have calculated or we have shown maxima minima thing, that is a stable equilibrium, by considering d2u by dr square. You can also find the same thing by considering, you can say what will happen if you take r plus delta r, and what will happen if I have r which is r minus delta r. So you can investigate both these cases and you can come to the conclusion that this is a case of a stable equilibrium. So I hope you like this video, and if you like, then please share with your friends, subscribe to my channel and promote this video by just making a like button. Thank you.